Hey kids, so today we are going to resume our class based on numericals that we had learned the formulae for in the previous class. So if you recall, we looked at something called as Snell's law, and we also looked at how to find out what is the critical angle. So today what we'll do, we are going to use these two formulae in two different types of sums that you might encounter when you go for your exams, right? So we'll start off with the first one. We'll start with the first law, that is Snell's law. And this is the question that we'll be solving for Snell's law. So if I read out the question for you, it says there's a light ray that is incident on the surface of air to liquid, right? And it makes a 45-degree angle. And then once it refracts, the refraction angle is 30 degrees. What we need to find, what is the refractive index of this liquid? Okay. So if I have to put it over here in terms of, let's say, things that I know, right? So generally we start our sums by writing what is given to us. So I'm going to first check out what is given to me. I know that this interaction is happening when light is going from air to a liquid, right? So I know ki the interaction is from air all the way to a liquid. Which liquid? We don't know, doesn't matter. Now, let's look at the angles of incidence and refraction that they have given us, right? So we know that angle of incidence I is nothing but 45 degrees, correct? And they said once it refracts, it makes a refractive angle of 30 degrees. Okay, now if you look at these two values, you can tell that the angle is reducing. It goes from 45 to 30, right? So that tells me this is moving from a rare medium to a dense medium, which is generally the case when it goes from air to anything, because air is a really rare medium, only second to vacuum, right? So I know that now I'm dealing with something that goes from a rare medium to a dense medium. If we want to look at it diagrammatically, it will be looking something like this. This will be your air, this will be your liquid, and the angle of incidence is 45 and the angle of refraction is 30 degrees. Now what's he asking us to? Find in this situation. What he's saying is, what is the refractive index of this liquid? Now, if I know Snell's law, which we do, it tells us one very simple equation. I told you can only remember any one. And if you remember that one, that's also sufficient to solve any sum, right? Sorry about that. So N1 sin I equals to N2 sin R is Snell's law. Now, I know some values in this, some I do not. Okay. So if I see N1 and N2, there is no mention over here on the left side. We have I and R, but now what is this sign? This sign is something that we are not familiar with. So I'll tell you for sums like this, where there's 30 and 45, there's a table that you can quickly refer to, wherein sine 30 is nothing but 1 by 2 and sine 45 is 1 by root 2. Another thing that you can do is look at this table over here. So this table lists out all the values from sine 0 all the way till sine 90. You can take 30 and 45 from here too. So if you see 30 says 0.500, which is 1 by 2. and 45 will be 0.7071, which is 1 by root 2. However, we don't need to deal with decimals when this sum is concerned. We always look for solving it in the easiest way possible. So I know now what is the sin I and sin r values. So what about n1 and n2? Okay, we know that n1 is for the first medium and n2 is for the second medium. Whenever you see air as a medium, you can directly take n1 as 1. Okay, we say the refractive index of air is equals to 1 by default. It's actually 1.0003, but we, for ease of calculation, we take it as 1. Now we know the values of n1, we know the value of sin I, we know the value of sin r. All we need to find is what is my n2 value. Simply start substituting the value over here. So n1 is nothing but 1 into sin I is nothing but 45 equals to n2 into sin 30 degrees, right? 1 into sin 45, 1 into anything is the same, right? It doesn't really matter. So simply write 1 into 1 by root 2 equals to n2 into 1 by 2. So I can put this as 1 by root 2 equals to n2 divided by 2. We can cross multiply this 2, send it all the way from here to there. So it will become 2 divided by root 2 equals to n2. Simple as that. Now, finally coming towards solving this sum. n2 is nothing but 2 by root 2. If you know roots, you know 2 is nothing but root 2 into root 2, right? You can do it that way, or you can take the value of root 2 directly as 1.414. But to make it simple enough, we do it like this. 2 is nothing but root 2 into root 2, because roots when multiplied for the same value get cancelled, right? Divided by root 2. So I can cancel 1 root 2 and 1 root 2 from here. The only thing that remains for me is n2 is root 2. The value of root 2 is nothing but 1.414. So therefore, I can write my answer like that. Therefore, n2 equals to 1.414. I think that's something that you know in math, the value of root 2. So for now, this is the sum that we will be doing on Snell's law. And this is how you solve anything that is based on Snell's law. Any one value will be missing. You need to find the remaining value. Just remember, air's refractive index is generally 1. Okay.